All right, today we're going to solve rational function equations. Now, back in Algebra 1, you may have encountered an equation like this, and you perhaps were asked to solve it by clearing out the fractions. To do that, you would have multiplied through by a common denominator, in this case 4. So you can see in the first expression, 3/4 x, the 4's would cancel out, and you'd be left with a 3x. In the second expression, you would have 20 over 2, which would reduce to 10, and then that would just equal 12. So now here you have a simpler equation with all the fractions have been reduced. From here, it's just a simple subtract 10, divide by 3 to get your answer. We're going to use this same exact philosophy or method in order to solve rational function equations. All right, so here is a rational equation. You're going to multiply through by a common denominator. In this case, it would be 4x. When you do that, your first term will become 2. Your second term will be 10x, and that will equal 7. And now it's a simple equation to solve. The one extra step now that you need to add when you're solving rational equations is you need to check your answer to make sure that it's not extraneous. If you take a look at the original equation, x could not equal 0 or you would be dividing by 0. So you need to plug your answer back into your original equation, really checking just the denominators to make sure that it doesn't equal 0. All right, why don't you pause the video at this point and try this one on your own. All right, multiply through by a common denominator. You get a simplified equation. You'll distribute, combine all your like terms, and solve. Again, remember your last step must be to check your answer, but the only thing that would make this equation have an extraneous solution would be -4, so this -40 over 7 works. Here you could do the same thing that we've been doing. You could multiply through by a common denominator, which would be 3 times 2x minus 1. But when I have one fraction equaling another fraction, another option would be to cross multiply. So I could say 3x equals 2 times 2x minus 1. And from here you can just distribute and solve. You still again must plug the 2 in and check to make sure that it works, in which case this time it does. All right, here you would multiply through by a common denominator, which would be x minus 3x plus 3. You'll need to distribute and combine all your like terms. You'll have a quadratic equation that you will solve by factoring. And you'll have two answers, x equals 3 or x equals 2. But when you check your answer, when you plug in 3, it's going to make your denominator 0. So 3 is not a viable answer. It's an extraneous solution, so you'll just cross it out and keep x equals 2. All right, go ahead and pause the video and try this one on your own. All right, multiply through by a common denominator. Did you get x equals 0 or x equals 3? Both solutions would work. There are no extraneous solutions. All right. Your equation would simplify. You need to multiply, combine like terms. Here you would need to factor out a 3x. You don't want to divide it out because then you will lose an answer. All right, go ahead and pause the video and try this one. First thing you want to do is factor this. You'll multiply through by a common denominator. Now you have a lot of multiplication that you need to carry out here, so you need to be very careful, not only with your math, but with your signs. You will have, again, a quadratic equation that you will need to factor and solve. You have two answers, x equals 1/2 or x equals -1. But when you check your answer, you can see that the 1/2 would make your denominator equal to 0. So that's extraneous, and your only solution is x equals -1. Let me know if you have any questions. I'll be happy to help you.